Welcome everyone. So this is discussion 13. We'll get started. Before we get started, any questions about the exam? You've graded your homeworks, your quizzes, and your R projects. Any questions? Any concerns? Okay. So in that case, I'll have a couple of announcements. The first announcement is about your projects. So your R project is divided into parts, and the first part is due on April 16th, which is on Thursday. So the way we are going to do this is you need to be able to figure out and come up with a short write-up of what data set you're going to use for doing an ANOVA or regression analysis. Okay. And it's a very simple thing. So all you have to do is like look for one data set that you're going to essentially rely upon for your next task. And the next task will involve you doing actual ANOVA and regression analysis. The second announcement is about the R part. So given the nature of these discussion, I'm not able to cover as much R as I would like to, because we kind of run out of time in most cases because we give a lot of time on problem solving. So I don't have a solution for that. What I'm planning to do is Peter has uploaded notebooks on Blackboard. So if you go to this directory called R stuff, you'll find multiple R Markdown notebooks, which you can either view as a PDF, or if you want to run it yourself, you're welcome to run it yourself as well. So in order to do the assignment and the project for ANOVA, all the commands that you need are actually there in the notebook. Okay, so I would encourage you to actually go and download those notebooks and run it yourself. That's actually a useful exercise than me trying to do it over this discussion, because I'm pretty sure we'll run out of time that way. Okay. So if you face any difficulty, because these notebooks are kind of self-to-do, so you should in principle be able to run each and every command, and all the commands that you need for the project, the assignments are there in those notebooks. Okay, so for people who join in late, if you're facing difficulty with the R part of the project or the assignments, Peter has uploaded notebooks on all the stuff that he's been covering in the class. It's there in the directory R stuff. Okay, so if you go to this directory R stuff, you'll find a list of notebooks, and these notebooks cover all the commands that you need. So there are examples for everything, how to do an ANOVA, and next week we'll also have regression stuff there. Okay, so the project should be very simple. Before you get started with the project, doing the analysis, make sure you read those notebooks. Okay. If you're not going to be able to run all the notebooks, at least go through the PDF, because the PDF shows you the command and the output. Okay, any other questions about the assignment or project or exam? Okay, all right, so we'll get started. I'm going to share my screen and turn off my video. Okay, all right, so if not download the notebook, if the handout, it's there on discussion 13 on Blackboard. We have two problems here, and I think we should be able to cover both of them. Before we get started, I want to just explain why do we care about doing an ANOVA at all, okay? So there are two versions of ANOVA that we'll deal with this in the class, and it's just, they're not explicit versions, but they're essentially a way to represent us the information in two ways. So the way one way ANOVA works is you have one categorical variable which has three or more levels. Okay, so what that means is you can think of these as three or more groups. Okay, so there's one particular categorical variable which has three or more groups. So last week we were talking about doing a treatment versus a control, but now we have more than two groups. So we want to be able to figure out, given group one, group two, group three, are the means of these three groups equal or not? Okay, this is an example. There could be more groups. And you have one continuous variable, and this one continuous variable value is what you get in these columns here. So this is C, C, C. Okay, these are continuous variables. So essentially, by given this kind of information, we are interested in identifying whether the differences between these groups are same or not. We have a slightly advanced version of ANOVA, which is called the two-way ANOVA. And the two here represents there are two categorical variables. Okay, so there are two categorical variables, but there's still one continuous variable. Okay, so that's the side about why we are doing ANOVA. So again, the motivation behind doing ANOVA is you're given multiple groups and you're interested in finding out, so the null remains the same, is the mean of these groups equal? Okay, so that's the motivation of doing ANOVA. Now you think of this in a hypothesis testing way, that if I just gave you, if you just had two groups, then this would be a very simple hypothesis to test. And we have already seen this in class, right? So you can either do a t-test, or you can do a Wilcoxon, or the paired or unpaired version of it, depending on how the data looks like, right? So why do we need a completely new testing strategy for more than two groups? So the reason we don't use t-tests, so if we have, let's say, three groups, one strategy would have been to compare mu1 and mu2. The other hypothesis that would be that mu2 is equal to mu3, and the third hypothesis would be mu1 equal to mu3. Okay, so these would be pairwise, so three pairwise t-tests. Now the problem with doing multiple t-tests is your type 1 error will be inflated. Type 1 error will be high. Why will it be high? Because we're doing multiple tests, and in each test there is certain chance of getting the rejecting the null hypothesis, even though it's actually true. And we are doing multiple tests of this, so everything gets multiplied, right? So it's almost three times the type 1 of one test. Okay, not exactly, but almost. Okay, and the other reason is this test, it's the variation that you will have in each of these groups is going to be different, and the pairwise t-test does not really take that into account in a global way, and we'll see how we fix that problem. Okay, is the motivation of doing ANOVA clear? So the reason we are doing a new analysis is because we have multiple groups. We are interested in finding out if their mean of all the groups are same or not. So one strategy would have been to do a pairwise t-test, but the problem with pairwise t-test is, number one, it has an inflated type 1 error rate, and the number two is the variation within groups is not handled properly. Okay, so the reason it's not handled properly is because you're looking at two stuff at once. You're looking at two groups only at once. Okay, so that was like a quick overview of what we are going to do. Let's look into the problem. So the problem here is given is you're given the GPAs of three different schools, and the college administrator claims that there is no difference in the first year GPAs of these students coming from three different schools. Okay. The first problem is very simple. The first problem is asking us to calculate the null hypothesis in words and symbols, right? So the null is there is no difference in the GPAs. Sorry. This is in words. And if I call this mu1, mu2, and mu3. Then my null in symbols is mu1 equal to mu2 equal to mu3. Okay. So again, an example, we have expanded from our usual 2-group theory to 3-group theory. Okay, that was simple. Part B, what sort of testing would you employ to test this hypothesis, right? So I've already kind of given you a hint as to what we are going to do, and we're going to do a one-way ANOVA. And why? So we just didn't arrive at this blindly just because we are talking about ANOVA. There's a reason to do this, is because we have one categorical variable, which is what school am I coming from? And it has 3 levels, which is the 3 groups that I mentioned. And there is one continuous variable, which is your GPA. Okay, and hence you're going to do a one-way ANOVA. Okay, so the next problem is, what would be a potential problem employing a pairwise t-test for the 3 groups to approve or disprove the claim of the administrator? Okay, so if we did if we did multiple t-tests, okay, if I did 3 pairwise t-tests, then there are 2 problems that will happen. First problem is you'll have inflated, or just to be clear, higher type 1 error. Okay, why? Because again, at each level of test that we do, I mean, at each one test that we do, we are creating one, we have some probability of doing a type 1 error, and we are doing 3 such tests, and hence we have a higher chance of creating that error. Okay, and the second is this is more of an advantage of ANOVA. So ANOVA combines the variability information between the 3 groups, and that's more advantageous. Okay, so I will not go much into the details. We'll see an example of what I actually mean by this, right? So we'll calculate what variation do we see in these groups, and that's what something ANOVA makes possible, but it's not possible if you do individual t-tests, because you're handling only variation of 2 groups at once. Okay. All right, so we'll move on to problem D. Problem D asks, how many degrees of freedom are there for the ANOVA F test? Okay, so what's an F test? So an F distribution is essentially given by something upon something. So it's given by essentially a ratio of 2 chi-square distributions. So xn square and xd square. N stands for numerator, D stands for denominator. So N is the number of degrees of numerator, and D is number of degrees of. Right? So what is this distribution, first of all? So we've already seen most of the times we talk about a Z distribution, right? So in some sense, it's essentially some version of a derived, so it's derived version of this Z distribution, but its distribution looks somewhat a bit skewed, and it has 2 parameters, right? The way it has 2 degrees of freedom. So remember, if we were talking about, just make it T. So if we were talking about T distribution, we had only 1 degree of freedom, which was uh, given by N, or whatever you want to call it. The corresponding degrees of freedom for F is given by, there's no corresponding degrees of freedom, first of all, but uh, analogously, the degrees of freedom for an F distribution is R2, and this is essentially given by the number of degrees of freedom in the numerator and the denominator. Okay, so it's just one other sort of distribution which certain random variables will follow, and we'll come on to how ANOVA does that. Okay, so in order to calculate the degrees of freedom for an ANOVA analysis, we start off with what's called n dot. And this n dot is essentially the total sum of the data points that you have. Okay. So if ni, so let's call it So N1 is 4, N2 is 4, N3 is 4. Ni equal to number of samples in the ith group. Oh, okay. Sorry. Been facing this static issue. So just to be sure, is the sound very noisy, or is it just that I stop in between? It's crackling. Okay. Let's see. Okay. Let me see if I can change my microphone. Okay. Is it a bit better now? Okay. Let me